The collection ADT is a more general storage structure where order of elements is not necessarily maintained. The assumptions is that this collection ADT supports addition, removal, and retrieval of elements. Retrieval is based on the user's supply of dot equals methods, where duplicate elements are permitted, null is not permitted, and addition, removal returns Boolean success values. So we see all of that across various different implementation details of collection in this chapter. We also see collection at the heart of many data structures, file system, memory storage, databases, so on and so forth. There are also many variations of collections. A lot of times people can call it bag, people can call it set, people can call it maps, hash tables, priority queue, so on and so forth. So you can think of a collection ADT as a general purpose ADT that aggregates and manages these elements. In the future, we're going to talk about the specific data structures that involves trees, graphs, maps, hash tables, so on and so forth. You'll be able to see a large variations of these collections in Java. Let's take a look. Most of the collection variations is inside the collection interface in Java, and they are part of java.util package of the library. So this interface supports up to 11 separate interfaces, including deck, list, set, etc. We'll look at Java collection framework quickly, just for your information. This is an image of the Java collection framework from Wikipedia. Inside this Java collection framework, we have a number of collection interfaces. And notice that there is a difference between framework and interface, which is represented by these ovals. So these ovals represent collection interfaces in Java. Notice that you have set interface, queue interface, deck interface, list interface, sorted set interface, and navigable set interfaces. Therefore, as we can see, some of these interfaces have sub-interfaces. As a whole, this entire Java collection framework provides the implementation of various data structures and algorithms. And this is all part of your Java util package. For example, this linked list class is one of the concrete classes inside the collections framework that provides the implementation of the doubly linked list data structure. And this array list is a concrete class inside this collections framework that implements dynamically sizable array. The reason why Java collection framework provides these various different data structures and algorithms is so that you don't have to write code to implement these data structures and algorithms manually. And they are much more efficient than if you were to write it yourself, as this collection framework is highly optimized in Java. We'll go through these various different data structures later to see how they are used. But we will try to step away from making you invoke these collections in Java in this class, because we want to study the underlying concepts, theories, and also implementation details of how each of these data structures are created and used.